Hi everyone, this is Dr. Diana Songsong. In our last video, we talked about geometric sequences. If you want to review the definition of geometric sequence, simply click the card above. Okay, so in this video lesson, what we are going to do is we will look for the nth term of a geometric sequence. So for example, you're given a sequence and you're asked to find the 100th term. You don't want to multiply 100 times to get the term that you are looking for, right? That will be too time consuming. Okay, so stick around and watch this video lesson.
Okay, so here is the nth term of this is the formula for the nth term of a geometric sequence. So a sub n here, again, it refers to the nth term. It is equal to a1 times r raised to n, where a1 is just your first term, and your r, of course, is our common ratio. And of course, a sub n, as I have mentioned earlier, that is already your nth term. So let's look at some examples. We want to find the 10th term of this sequence: 5, negative 10, 20, negative 40. Now, let me just write our formula for the nth term. A sub n is a1 r raised to n minus 1. Now take note that a geometric sequence is defined by its first term, a1, and its common ratio. So remember that if you have a geometric sequence, it's always important that you know what your first term is and what your common ratio is. Okay, so since we are looking for the 10th term, we are looking for a sub 10, correct? So in our formula, it's equal to a1 r raised to what? It's equal to, take note that if this is n, this is the exponent that you need for your common ratio is n minus 1. You subtract 1 from that. So therefore, if this is 10, the exponent here should be equal to 10 minus 1, or 9. Okay? And then, we just plug in the values for a sub 1 and r. What is our first term here? Our first term here is 5. Okay? And then, what is our common ratio? Again, from our last video lesson, it's equal to right over left. If you want to review on that, please click the card shown above. Okay? So what is our right over left? That's negative 10. I'm looking at this first two terms, negative 10 over 5. So that's equal to negative 2. So that's our r. So I will now plug that in. A1 is 5 times my r is negative 2 raised to 9. And what is that? Okay, take note that we follow PEMDAS here, meaning to say we start with what? PEMDAS. So you start with exponent. Don't multiply 5 and negative 2, because you're saying there that multiplication comes first before exponent. Okay, let me just write that down, the PEMDAS. Take note here that, again, exponent comes first before multiplication. So that's why we have to evaluate first negative 2 raised to 9. Okay? Let me just erase this so that we have space. Okay. You might be asking me that, hey, negative 2 raised to 9 is such a large number, and does that mean that I would have to multiply negative 2 with itself 9 times? That might be so tedious. Okay, so what you can do is this. First, what is the sign of negative 2 raised to 9? Since you are raising a negative number to an odd number exponent 9, that means that the the sign is negative, right? And then you just have to compute what is 2 raised to 9. Now, to make it easier, take note that 2 to the 9 is equal to 2 to the 5th times 2 to the 4th, right? Remember, let us recall from the laws of exponents, when you are multiplying two numbers which have the same base, what do you do with the exponents? You add, right? Okay, so anyway, at least for 2 to the 5th, that's not so bad. 2 to the 5th is 32. 2 to the 4th is 16. Okay? So therefore, 32 times 16, oh, what is that number? 32 times 16, you get 12, 18, 19, 32, 2, 11, 512. Okay? So therefore, this is 5 times negative 512. So what's the answer? 5 times negative 512, that's negative, this is 10, 6, 2,560. Understand? So again, what happened here is that we simply used this formula and we plugged in our values for a sub 1 and r. Next, we want to find the 15th term of this sequence. So again, let me write down our formula. an is a1 times r raised to n minus 1. But since in this case, we are looking for 15th term, so our n is equal to 15. So that's a sub 15 is equal to a1 r raised to 14, correct? Because our subscript here is 15, subtract 1 from that. What is our a sub 1 here? Our first term is 1/2. What is your r? Actually, it's easier if you will look at this one, 2 and 4. What do you need to multiply to 2 in order to get 4? That's times 2, right? I did not bother with the right over left here because I think this is just a small number and you can easily see that the number you need to multiply to 2 to get 2 is 4, okay? So our r is 2. Okay, and then same thing, just like with our previous example, plug that in. 1/2 times r. So that's, my r is 2 raised to 14. Okay? And then, what do we have here? 2. Look at this class. How do you divide 2 raised to 14 over 2? Let us recall your laws of exponents. If you have a raised to m over a raised to n, what do you do with the exponents? You subtract, correct? So therefore, in this case, our exponent here is 1. So therefore, what do? You copy the common base, which is 2, just like what we have here. Copy the base, and then you subtract the exponent. So we have 14 minus 1. Oops, it got erased. So that's 13. Actually, for me, 2 raised to 13 is okay. If your teacher wants the number which is really equal to 2 raised to 13, that's fine. You can easily compute it. But for me, I guess 2 raised to 13 is already okay. Alright? Okay, next. In this example, we want to find the indicated term of this subgeometric sequence. But this is actually easier because we are already given a sub 1 and our r, so there is no need to compute, just like in our previous examples, right? So it's just a matter of direct substitution. Again, let us write a sub n, a1 r raised to n minus 1. But since we are looking for a sub 9, n is 9, so that's a1 r raised to 8, okay? And then a1 is 9 times my r is 1/2 raised to 8. What is that? 1/2 let me write it here. 1/2 raised to 8 is 1 raised to 8 over 2 to the 8, correct? Laws of exponents. Recall that if you have a over b raised to m, you simply distribute the exponent, correct? So this one, m, you distribute it to the numerator and denominator. Okay, but 1 raised to 8, 1 multiplied to itself 8 times still 1. 2 to the 8 is, actually you can use the same technique that we had earlier. You can write it as 2 to the 4th times 2 to the 4th, okay? What is 2 to the 4th? That is 16. So 16 times 16, that is 256. So that's 1 over 256. So this is 9, 1 over 256. So our final answer is that 9 over 256. Okay, so for this one, try to pause your video and answer the following problem. Okay, assuming that you have paused your video, let us now discuss this. We are looking for a sub 5. And what is the formula for a sub 5? A1 times r raised to 4, correct? A1 is 5 and then r is 3 and then raised to 4. And then again, we perform the exponent first. This is not equal to 15 raised to 4 because again, you're saying there that multiplication comes first before exponent, which is not the case. Anyway, so you have to compute 3 raised to 4 and that is equal to 81 times 5. So 5 times 81, you get 405. So that's the 5th term. For our next example here, we are given the general formula for your nth term and you just want to find the first 3 terms. So therefore, it's just a matter of plugging in, right? So for the first term, for a sub 1, that is 4 times 2 raised to 1, right? So therefore, that is 4 times 2, so that's 8, right? What is a sub 2? That is 4 times 2 raised to 2. I am simply substituting it to this formula here, where here n is equal to 1, n is equal to 2. So that's 4. 2 squared is 4. 16. What do you think is the next term? A sub 3 is 4 times 2 cubed, correct? So that's 4 times 8, so that's 32. Now for this, I just show this to you so that you understand the meaning of a sub n. But just by looking at it, it is actually a geometric sequence because the form is, look at the form, something raised to an exponent. So from here, I can easily see that the common ratio is 2 because that is the number that is the base of your exponent. So what I do is I just get, once I am finished with my a sub 1, okay, a sub 1 is easy to compute, right? Because n is equal to 1. So since I already know that my first term, my a sub 1 is 8, and from here, from this box over here, my common ratio is 2. So that's why I know that the next term will be times 2 times 2. So that's why I have 16, and then 16 times 2 is 32. Understand? So let's do that for this next example. Actually, look at the form here. This is actually here. And it's already of the form a1 r raised to n minus 1. Correct? Look at the form already. So it's already telling you that your first term is 3. with what is your common ratio? Your common ratio is negative 1/3. So that's it. So you have times negative 1/3 and then times negative 1/3. So 3 times negative 1/3 is negative 1. And then what's the next term? Negative 1 times negative 1/3, you get 1/3. Understand? Okay, now for this example, we want to find a formula for the general term. So it's actually, what is the meaning of find a formula for the general term? You just want to make something like a sub n is equal to what? Okay, but remember that we already have a formula in general. It's a1 r raised to n minus 1. But from here, our first term is 6. What is our common ratio, class? Our common ratio is 2. Correct? 6 times 2 is 12, right? So 6 times 2 to the n minus 1. This is now your formula for the general term of this sequence.
Thank you for watching my video. Don't forget to subscribe to my channel and also watch for more videos here.